For more information, please visit SGMAK Associates website.
In this module, I have an example on capitalized cost. I've defined capitalized cost before in another module. I present another example, and then I discussed a couple of examples where you estimate net present value of a project and take decision depending on the value of the net present value. The basic rule is a project is good if it has a net present value greater than 0. When you compare alternatives, you always select the one with the highest net present value. First example, you want to set up a scholarship fund that should generate $10,000 a year for every year forever. The fund selected has a variable earning rate. It promises 8% APR for the first 5 years. It drops to 7% in the next 5 years, and then it promises to earn 6% thereafter. Question is, how much one-time initial investment will allow you to maintain this fund, this promise of scholarship? So the cash flow diagram is shown here. You want to withdraw from the fund $10,000 every year. So you have an unknown amount of initial investment, X. And as you can see, the interest rate changes. First 5 years 8%, then changes to 7%, and then end up from 10 years onward changes to 6%. We want to find the value of X, the initial investment. So first we find out what's the remaining balance from the fund after 5 years, having made first 5 payments, earning at a rate of 8%. We designate that as an RB1, and remaining balance is given by the future value of the initial investment, X times F over P, 8% 5, minus what you have taken out from that fund, $10,000 multiplied by F over A, 8% 5. So you're taking all cash flows at the end of year 5 to find out how much still remaining, having made the 5 payments. You have an expression for that, and which carries the variable X. Now let's look at remaining balance at the end of 10 years. Because from year 5 through 10, we are earning at a rate of 7%. So following the same logic, we are starting the period with the remaining balance RB1. That's like an initial investment. So we find remaining balance at the end of year 10, RB2, is RB1 times F over P, 7% and 5. Look at the change in interest rate, minus what you have withdrawn. You're withdrawing $10,000 every year. 10,000 times F over A, 7% and 5. So that's what you have at the end of year 10, and you got an expression that carries the unknown amount, unknown variable, unknown X. So you got RB2 as 1.403 times RB1 minus $57,510. Now, end of 10 years, the fund earns 6% forever. So following the principle of capitalized cost, all that you're withdrawing from the fund is just the interest earned. So RB2 times 6% converted gives you 0.06. That should sustain $10,000 for the remaining period. That gives you RB2 as $166,666.67. Gives you a value for RB1, $159,783.79. And you solve back, the value of X is $148,000. $148,709.18. So about $148,000 $709 initial investment will be able to sustain the scholarship fund forever. We're just computing net present value. The problem statement reads like this. You got initial purchase price is $20,000. You got annual operating cost of $1,200. You don't have maintenance cost for the first 2 years because it is provided by the OEM. Then it kicks in from year 3, $1,500 end of year 3, and that's the annual cost from then on. Then you got an additional expense of $4,000 one time at the end of year 6. Useful life is 12 years, and the equipment is expected to generate a salvage value of $3,000. Use a discount rate of 6% APR. All cash flows are yearly in this example, and estimate the net present value of the project. So the cash flow diagram captures all the costs: initial expense of $20,000, annual maintenance, operating cost of $1,200, the maintenance cost kicks in from year 3, and one-time additional cost of $4,000 end of year 6. Only benefit that you have is $3,000 salvage value. So net present value is simply net present value of all benefits minus net present value of all costs. So salvage value, we brought it to from future to present. 20,000 initial cost is right now. Then you convert annual maintenance, annual operating cost to present, and then you got annual maintenance cost. Look at the factor, starts from year 3. So what you have done here, we have first we have brought P over A 6 and 10 at the beginning of year 10, and then he brought it for over 2 time period to bring it to the present. So look at the use of these 2 cost factors, conversion factors. And salvage value is one future value brought to the present. And using the table lookup, the value comes out to minus $41,215.40. So basically, with the data given, all that you find is the net present value of cost exceed the net present value of benefits. Well, in this case, all the benefits are not provided, but with the data given, that's the net present value for the project. Let's look at the next example. You got an initial cost of the machine $750,000, generates an annual benefits of $150,000, useful life of 10 years, and has a salvage value of $25,000 at the end of his useful life. That's a typical structure: initial cost followed by benefit and some annual cost and annual benefit, and then a salvage value at the end of useful life. We're using a discount rate of 8%. We want to find out whether we should purchase the machine. We'll purchase the machine if the net present value is greater than 0. So we have shown the cash flow diagram. Initial cost $750,000. A is the annual benefit of $150,000, and you have a salvage value S, $25,000 at the end of useful life of 10 years. So net present value of benefits minus the net present value of cost. You got 2 benefits, one on annuity and one in the salvage value, and you just got initial cost. So put the appropriate factors here. Annuity gets converted by P over A, and salvage value future to present, so use the factor P over F. Discount rate is 8%, useful life 10 years. So that gives a net present value of $105,550. Net present value is positive, so project is good. We'll recommend purchase of this machine. The next problem, where you're comparing 2 alternatives. So when you compare two alternatives, they have equal useful life. So you'll be using based on net present value. Select the one that has a higher net present value, provided both are positive. You don't consider an alternative if the net present value is less than 0. It drops out from further consideration. So what we have here, we got alternative X and alternative Y. You're given the initial cost, annual benefit, and salvage value, and useful life for both happens to be 10 years. So you find the net present value of X, net present value of benefit minus net present value of cost, and it comes out to be $7,744 negative. Since net present value is negative, we do not select X. It drops out. Now let's look at Y. Same reasoning, but its net present value comes out to be $36,288. Is positive, so we select Y. So in this case, X is out of consideration, so only Y remain in the competition, and Y has a net present value positive, so we select Y. So when you're comparing two alternatives based on net present value, X and Y, in general, if you find net present value of X is greater than net present value of Y, we select X, provided both net present value are positive. Drop an alternative from further consideration if net present value is less than 0. Use the net present value approach when useful lives are equal. Hopefully, this will be of help to you. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.